Hello guys, welcome to another session here at Afya Data. One of the, if not the fastest, yes, the fastest growing health data science space for you to learn and get the hang of health data science. All right. So welcome back. We were looking at or we were doing a series on pharmacovigilance in Python. And previously, we had seen how we can get side effects reduce data to help us understand this process. So remember, the whole essence of this series or the idea of these sessions is for you to understand the workflow that happens when dealing with these kinds of projects. So you won't be an expert through just seeing this episode. Neither will you like learn everything, but you will appreciate the process that happens so that you can be able, if you are trying to learn, that you can able to see where to focus on. I think that's the most important takeaway you can have from this series. So we had previously gotten our dataset on side effects reviews. It's text data, which even makes this a whole lot interesting because there are very few resources out there that helps you understand how to deal with text data and machine learning. And the essence was to develop a practical intuition to natural language processing in health data science. And our focus is on pharmacovigilance and pharmacovigilance in Python. So previously we had said we'd do this in VS Code, but we decided let us do in Colab because Colab is easy. You can just load it up on your browser and get started. As simple as that. Okay. So the link, I'll leave the link to this notebook down in the description for you to follow along. But if you followed us in the previous episode, I will ask you to reload the cells again because I've added another data set over here, and I will explain what it does in a few. So we will just rerun the cells again. We had loaded up the data set and saw what it had. We had done some basic exploration, which I said in health data science, that's something very important for you to do. However, what we did here was very, very minimal, but EDA or exploratory data analysis is normally like takes the biggest chunk when you're dealing with data. You want it to be in a format in which it can help you get outputs or help you do analysis that you can communicate to your different stakeholders. Okay. Then we had seen how to handle missing data like this. So I'm just running through this because we had all covered this in the previous video. So in this next bit, we will do what we call encoding labels. So in this case, we are turning just text to numbers so that they can be labels for us to build classification models using. As simple as that. So this workflow looks different within the current frontier models that use LLM, but the real takeaway here for you now in this particular video is how to understand how this process happens in natural language processing or NLP. Okay. So to begin with, first we take that side effects column of ours and turn the category into numeric labels so that the machine can use to predict. All right. So our category consisted of side effects, no side effects, mild side effects, moderate, severe, and extreme. And we represent this with numbers or new label so that we can be able to predict that. So how to do label mapping in Python? We normally use something called dictionaries. So dictionaries maps each category name to its numeric label. So each category becomes a key and each numeric label becomes a value. All right. So that's how we pair them in Python. And then we use this function called .map, which now maps this dictionary that we have onto our column, which is in our data frame. As simple as that. So just you can just rewind and understand just what I've said. Okay. So once you've done that, you see that we are able now to get a new column of side effects that has new labels which are distributed across 0, 1, and 2. And you can see majority of the distribution is at 1, where 1 is mild side effects and moderate side effects. Okay. So we are good until there. Let's continue. So next step after you've done your labeling, now you go to your side effects reviews. Okay. So this part is more of the history. It's like a little bit of the history of NLP, because what used to be done back then, we needed to prepare the dataset very well for the model to handle. Okay. And currently, LLMs, I think, are doing a much better job of doing this by doing it under the hood without you really knowing what's happening. Uh, but when you don't have an LLM or access to something that has transformers, this used to be what you did then, right? So what we do first, we prepare our dataset, and then we use these steps to prepare our dataset. So what we do, we turn the column which we are interested in, which is the effects review. We look at the data over there, we turn them to lowercase, we remove special characters like punctuation and symbol and any other noise. We remove stop words, that is common words like they, are, those words that don't have really any clinical meaning, because you can imagine if we train our model with words that have they, are, and all that, the model will be looking for those stop words to make a prediction, while we know those stop words are not very important for us to understand the severity of side effects. Then you do something called lemmatization, which is simply to reduce words to their base form. Like, for example, someone might say running, but we just want the run bit, which communicates enough medication to medication. So these are the examples of lemmatizing word. So you're just turning them to their base format. Then removing digits. Numeric numbers are usually not informative in this context. Okay, so these are the steps that will be done during this process of text processing. So for that, we need what we call stop words. So we need a pool of stop words that we can reference, so that we say, given these stop words, I want you to check on my side effects columns and remove all these stop words from this list. So that is what this dataset stoppers.txt is doing over here. So when I load that, you see we've loaded 1,298 stop words, and here are the sample. It's 1039. There are a couple of them. So this is an example of what we used to do in most cases, where we used to have a library, or how can I put this? Yeah, more of some stopwords that we know or are common. We use that to clean our text of interest with. So in this case, side effects. Okay, so after we've done that, we can run this next bit of cell where the pre-processing happens. So for the pre-processing, remember I said we will do this stepwise. So over here, we have what we call a function. So this function takes a data frame and a column name and cleans the text within that data frame. So we define it once and can call it on both our training and test data. Okay, so just to explain to you what is happening here, we have a data frame that has side effects. Okay, so on that column of side effects review, there are a number of texts. But before we prepare this text into a format in which our model can understand, we need to clean it. So we need to clean it by removing stop words, by removing numbers, by doing what we call lemmatization and what so. So for us to do that, we create a function. So this function, we call it preprocessing or preprocess, which basically takes a data frame, takes a column, and runs that function within that column. As simple as that. So this is a very important step because it prepares our data ready for cleaning. So I will just run this function, and this function now is stored. So that means that we can call upon this function later on different different data frames, like the training data frame and test data frame or test data, and we work and let it work on the specific columns. So some of the steps within this function include turning them to lowercase, removing characters, removing extra white space, and removing stopwords. Again, remember, the whole essence of this video is to give you an intuition on the workflow that happens in this case. So let's see what a review looks like before cleaning. So let us look at an example of a review, what it looks like before cleaning, and see the importance of doing this step. So when I run that, before cleaning, this is what we have, for example, in a review at number 1. So let's see so in Python, 0 is essentially 1. So just keep that in mind if it's your first time in this session. So this is how a review looks like. Let's look at another one and see. Let us look at, for example, number 6. That's number 7. So for example, here it's a good. So this is a good review actually. So a review by the patient says a few experiences of nausea, heavy mood swings on the days I do not take it, decreased appetite, and some negative effect on my short-term memory. So let us apply the cleaning and see what happens. So the preprocessing happens, and then we have more of a cleaner. Also, there's number. So we're doing it at number 6, position 6. Sorry about that. So let us clean, and then we see we remain with this. So from this to this. So you see how we've taken care of some things where we've removed things that we believe wouldn't be necessary in our case, and just remain with a length of string that we can be able to work on our model. So the thing here is that this step, not much of it is being done in the current LLM models. They have a better way of handling this, or sometimes it happens internally. So we will talk about that later when we get to that bit of kind of complex stuff a little bit. All right, so next we do what we call lemmatization using what we call spaCy. So this is another important library. So spaCy is a professional grade NLP library widely used in clinical text processing and biomedical research. Okay, so as I said, lemmatization is just turning words to their base format. Okay, so to do that, we need to load up spaCy. So for us to load up spaCy, we say import spaCy, and then we need a model that will run that spaCy library. So in this case, we need to load a small English language model. So this model understands English grammar and can identify word forms. So you might first need to load up this spaCy model. So let me just load that up, and then we can continue. Okay, so these 2 cells finished running. They took about a minute. But anyway, what now we'll be doing next, we will now be using the spaCy library to help us load a model, which this model will now help us do this lemmatization process. Okay, so remember when I said the current frontier models handle these things way more efficiently? Before that, what we used to do, we used to have a library that has access to some model. So in this case, maybe a small English language model that will help us carry out this lemmatization task, so that we can be able to prepare our data well for this particular task of classification. So first, remember we have a whole column of training data, and we have also a whole column of test data that have side effects reviews. So what we need to do, we need to convert those side effects into their base format, so that we can predict whatever is happening using the base words. All right. So that's a little bit of a mouthful, but it's an important step for you to understand, or for you to know exists, so that you can be able to prepare your data for modeling. All right. So once we've loaded the model, we need to create a make to base function which handles this step. So this one is just over here, and it's handled by the model. I want to go deeper into it for now. So once you've done that, we press this next cell, which now transforms each review from inflected words to their base forms. So this again may take a minute depending on which computer you're using or your network. So after doing that, this is what happens basically. So the words have been lemmatized. So let me see if they provide an example. Mhm. They don't over here, but let's continue. So the final text cleaning pass. So after lemmatization, we do more rounds of cleaning to remove any digits or punctuations that may have been introduced and to apply our stop word filter again to the newly lemmatization, to the newly lemmatized words. So again, this is another round of cleaning just to prepare our data for our ML task. So we create another function called clean text. So if I just go up, you will see that we had this function here called preprocessing, and it does its function, it does its work. But over here now we have another function called clean text that also helps us do some cleaning. So the steps are laid out over here, like turning it into lowercase, removing digits, punctuation. So another extra step of cleaning. And then after that, let us do some cleaning to both datasets. That's to both the train and test dataset, and see what we have. So this is how the final dataset will look like. A little bit clean, that will help us do some analysis. All right. So this is what we have, and we are ready to continue. Okay. So this section is actually important. I know I've just run over it quick, but just to do a basic recap, the idea here is to pre-process the data, to pre-process the text data. That's all you need to know from this video. That's what's happening. So just to begin from the top, you have the dataset, you have loaded the dataset in your environment, you have looked at the shape, the information in which the dataset has, you've handled the missing value, you've labeled your dataset, then you do some pre-processing. In this pre-processing step, there is an additional step of loading up a model, which allows you to do lemmatization, which is just basically turning your word or reducing your word to their base format. That's all that has happened here, which is something important to keep in mind. So if you can't remember much from this video, just remember that short summary that I've given you. And you can run this cell over and over again, or this notebook over and over again to understand what's happening. Okay, so we've done that. We've cleaned that. Next goes to feature extraction. All right, so here in feature extraction, this is an important step. So these two section 6 and section 7 are very important now when it comes to ML, and where your health data science antennas needs now to light up. So I don't know if I want to do this in a separate video. Okay, let me just introduce it, and then maybe you will be able to grasp what is happening. So strap in a little bit. This is about to be a much longer video than I anticipated. So here, under feature extraction, we normally do some couple of steps. So when you're doing machine learning, and when I say machine learning here, it means you are not using an LLM to help you through this step, or to help, like, it's not an LLM that is running within this model. Machine learning algorithms normally cannot read words. They only understand numbers. So we need to convert each patient reviews into a numeric representation. So that's very important. So this numeric representation is different from the labeling that we did up there. So for the labeling is like, the question here is, given a side effect, should it be mild or severe? And then for the mild or severe, because the model cannot understand what mild is and severe is, they say, for example, 0 or 1. But here, we need now to look at that side effect. So given this side effect, because the model cannot read it, we need to convert this into some sort of numeric representation. So that is what is happening in this step. So here, we will use what we call TF-IDF. So that is called term frequency inverse document frequency. So this is an algorithm, all right, that helps us handle text data. As simple as that. So what is TF-IDF? TF-IDF normally assigns a score to each word in a document based on two things. The term frequency, that is how often this word appears in that review. So for example, a word that appears many times in one review is likely important to that particular review, all right? And then the IDF part is inverse document frequency. So how rare is this word across all reviews? So a word that appears in every review, like drug, probably less informative than one that appears in only a review like anaphylaxis. So what they mean here is that when you have, let's say this is one review, this is two review, there's a third, there's a fourth over here. So when a word appears in this one review, if a word appears many times in this review, then chances are this word is important in this review. Okay? So that's what term frequency handles. Then inverse document frequency looks at how many times has this word appear in other reviews over here. So if this word only appears in this review, then that means that that word is important to this review. But if it appears everywhere, then chances are it's just also a common word and doesn't hold much weight for us to be able to identify how much significant that word is to a particular review, right? So the result, common but uninformative words get normally a low score, while rare but meaningful words, especially clinical terms, get a high score. So the clinical analogy here is that TF-IDF is like a lab result or a reference range. It tells you not just what the values are measured, but how unusual it is relative to the population. So what is max features? So TF-IDF creates a column for every unique word in a dataset, which could be tens of thousands. And the max features, we just look at, because we don't want to inflate our features, we need to have a max limit. So limits this to only the most important words. Okay, so we will use hyperparameter tuning to find the optimal number. So I will dive deeper into this when we look at the model training and helps you understand. So the reason we are going through this step actually is for you to be able to understand how to troubleshoot a problem within the machine learning pipeline in health data science. So this is it's a little bit complex in terms of where you are if you're a beginner. But it is important for you to understand that these are the things that are involved within this space, especially when you're talking about text data and health data science and modeling in general. So just be aware of these concepts and that they exist. So to do that, we import the libraries we need for machine learning, and NumPy is a standard library for numerical operations in Python. And then over here, we'll use another library called sklearn or scikit-learn, which we convert text into a TF-IDF matrix format. Okay, so this is what this cell does. Let us run that and see if it runs. Okay, so we've run that. Let me see if there's anything. Okay, we've separated our data. Okay, that's fine. So next is now finding the optimal number of features, the hyperparameter tuning. So remember when I said that when we look at all documents or important parts of all documents, we will have an inflated parameters. So for us to handle the number of features in this case, we use a term called, we do some steps called hyperparameter tuning. So how do we know how many features or words to keep? We try several values and pick up the one that gives the best model accuracy. So this is what we call hyperparameter tuning, where we optimize the settings of our algorithm before training. So think of it like this. We have an algorithm over here, and we want this algorithm to help us convert text data into numeric format. But this algorithm, if we don't give it proper instructions, it will waste time and look at everything. And when it does look at everything, this creates a problem in computing, which the computing is very large, right? So before we do that, we need to tune this algorithm before it does this search on this data set for training purposes. So in this case, we call that step hyperparameter tuning. So we use grid search CV, which tests every value we specify, uses something called 5 cross validation, where it splits the training data into 5 parts, trains on 4, validates on 1, and repeats the step 5 times. So I might go a little deeper into cross validation in other sessions. So it returns the value of that, the value that gave the best accuracy. So cross-validation, okay, let me just mention here. Cross-validation is like running, okay, do I want to explain it in this format? So I'll just skip this for now. But what cross-validation does in this step, it takes the training data, it splits it into five regions, then it trains on 4 and validates on 1, and then it repeats again in another step. So we do that like 5 times. So I know I haven't defined it properly, but just be aware that there's a step called cross validation that happens, and then when we get into it in some other video, I will dive deep into that. So here is where the important step of optimizing our numbers for features, or that hyperparameter tuning in short, happens. So this bit here, so I just want to show this bit here is now one of the important places where you need to understand machine learning. So if your goal is to understand machine learning and machine learning research and what happens, I think hyperparameter tuning is one of the areas that you will get to, and your mind will click like, oh, so this is where machine learning happens. So when you hear people talking about machine learning research in various avenues, this is one of the areas that people are really interested into looking at. So I'll just run this cell. So let us see. So that cell will take a while. So I'll be back once it finishes. Okay, now this cell has run. So I want to go deep into this, the hyperparameter tuning that I've just explained, but I think we will get back into this and see how this step is very important, especially when we are doing the grid search. So this normally involves some of the areas that people are really concerned when they deal with machine learning research. So later on, when we want to dive deep into the nitty-gritty of ML, we will look into this. But for now, our most important thing is to understand the workflow that happens when you're dealing with such task. And then after doing this parameter tuning, we get a maximum features of 850, which may give best accuracy of 0.52. This is when we use logistic regression as a model. We won't dive into that for now. And then we run this cell, where now we come up with a table of the maximum features that we have and the rows that we have. So here now we see that our TF-IDF training matrix shape has 332 rows and 850 columns. So let me just close this video by saying, here we have 332 and 850. So what I want you to understand is when you come back here, let's see let's come back on top. Here we had 3,332 rows and 9 columns. So we cleaned this, and then we got where is it? Yes, we got this. So we had 332 training rows, and then we actually had three. We had 3 columns. Sorry, we had 3 columns. 1, 2, 3. But right now we have 332 columns, 332 rows with 850 features. So why is that so? So the important thing here is to understand that TF-IDF happened. So by doing TF-IDF, which is the process that I explained that helps us turn this text data into numeric data, we are able to get 850 features. So we will use those 850 features to now train our model. I don't know if that makes sense. So remember when we started with 9 columns, and then we went down to 3 columns to allow us to work better on those kind of to focus on that area. But all of a sudden, these 3 columns have turned to 850 columns. So in this case, this representation of this data is in a form of what we call a matrix. So this matrix has 8 rows and 850 columns, which are features or words. So I want to stop there, but before I stop there, let's just recap what has happened from the beginning to where we are. And the important thing here is for you to understand the workflow. So number one, we loaded the dataset. We got the dataset from side effect reviews and we loaded it into our space. So here we're using Google Colab. Then number two, we explored the data. We saw what was happening in the data. We're able to identify the shape of the data, what it looks like, and those kind of things. Then number three, we selected relevant columns for us to work with. Okay, so this was the side effects reviews and side effects, and we thought, okay, maybe we'll need conditions at some point, but we only had those 3 columns to work with, right? Then we moved a step further and handled missing data. And we talked about how handling missing data might look like differently depending on your project, with the project, right? After that, we do what we call encoding. So we encode the labels. So these side effects, we said they could be mild, they could be moderate, they could be severe. We need to encode that outcome so that the machine can learn that outcome, because it cannot learn text. Then we encode it in a way that it can be able to learn the numbers. So in this case, we had 0, 1, 1, and 2. Then after that comes an important space of text preprocessing. So this text preprocessing was layered. So it was layered into different steps, where we did an overall preprocessing by removing some stopwords. We did some overall preprocessing by turning them into lowercase, by removing some how can I put it? Am I forgetting the name? Some punctuations, some dashes, that kind of preprocessing. And then we did what we call lemmatization, using a small model using the spaCy library. So again, the essence is just to understand the workflow, what's happening. And then after that, we did what we call feature extraction, whereby we took this column of side effects review that we had cleaned, and we sort of extracted features that we will use to train our model. And in this case, well, the reason we are doing that is because the ML cannot understand, the machine learning model cannot understand these texts plain. We need to transform them into features that Unity can understand. And here we used a method called TF-IDF. So that's all you need to take from here. And then we will finish in the next bit by now looking at the machine learning part of it. Okay, so that was a mouthful, but in essence, that's the workflow that happens. So when you're trying to get into machine learning, or when you're trying to get into this workspace, these are the important things that needs to be at the back of your mind, sort of like goals you need to engrave at the back of your mind as you do your training or you're working to try and learn machine learning or health data science in general. Okay, that was a mouthful. I've talked too much. So please, if this information is helpful, if you're learning something from them, please share with your friends or your general community that are learning health data science, and be sure to leave a like, subscribe, and even comment further down below. Until next time, see you.